Hello and welcome to part 7 of the lecture series. In this video you will learn how to find number of non-negative integer solutions of equation 3x1 plus 5x2 plus x3 plus x4 equals 10. I will explain two approaches to solve this problem. In part 6 of the lecture series we learned how to find number of non-negative integer solutions of linear equation in which one of the coefficients of variable was not 1. You can view that video by clicking this card. Now we will learn finding number of non-negative integer solutions of linear equation where two or more variables have non-unity coefficients. Before solving this problem, allow me to ask a question. What will be the possible values of x1 and x2 such that left hand side of equation 1 does not exceed 10? Let me help you to figure out. If value of x1 is greater than or equal to 4, there would not be any solution because in this case left hand side of the equation 1 becomes greater than or equal to 12, even if x2, x3, x4 are 0. It means x1 could be either 0 or 1 or 2 or 3. If value of x2 is greater than or equal to 3, there would not be any solution because in this case left hand side of equation 1 becomes greater than or equal to 15, even if x1, x3 and x4 are 0. It means x2 could be either 0 or 1 or 2. Further, the sum of x3 and x4 is greater than or equal to 0 because x3 and x4 are non-negative integers. Hence, the only possible ordered pair solution of x1 and x2 are 0, 0, 0, 1, 1, 0, 1, 1, 0, 2, 2, 0 and 3, 0. Now we will move terms containing x1 and x2 on right hand side of equation 1 to get equation 2. Now we have exactly 7 different ordered pair solutions for x1 and x2. When x1 equals 0 and x2 equals 0, x3 plus x4 equals 10. And the number of non-negative integer solution of this equation is 11 factorial divided by product of 10 factorial and 1 factorial. When x1 equals 0 and x2 equals 1, x3 plus x4 equals 5, and number of non-negative integer solution of this equation is 6 factorial divided by product of 5 factorial and 1 factorial. When x1 is equal to 1 and x2 equals 0, x3 plus x4 equals 7, and number of non-negative integer solution of this equation is 8 factorial divided by product of 7 factorial and 1 factorial. When x1 equals 1 and x2 equals 1, x3 plus x4 equals 2. And the number of non-negative integer solution of this equation is 3 factorial divided by product of 2 factorial and 1 factorial. When x1 equals 0 and x2 equals 2, x3 plus x4 equals 0, and number of non-negative integer solutions of this equation is 1 factorial divided by product of 1 factorial and 0 factorial. When x1 equals 2 and x2 equals 0, x3 plus x4 equals 4. And number of non-negative integer solution of this equation is 5 factorial divided by product of 4 factorial and 1 factorial. When x1 equals 1 and x2 equals 0, x3 plus x4 equals 1. And number of non-negative integer solutions of this equation is 2 factorial divided by product of 1 factorial and 1 factorial. According to addition principle of counting, the sum of number of non-negative integer solutions of these 7 linear equations is equal to the number of non-negative integer solutions of equation 2, which comes out to be 36. Also, the number of solutions for equation 1 will be same as the number of solutions of equation 2. Using second approach, that is blue and yellow ball method, here we have total of 10 minus 3x1 minus 5x2 blue colored balls, which equals to right hand side of equation 2, and one yellow colored ball, which is equal to number of positive sign on left hand side of equation 2. We have a total of 11 minus 3x1 minus 5x2 balls, out of which 10 minus 3x1 minus 5x2 are of one kind and 1 is of second kind. So the total number of ways of arranging these balls equals 11 minus 3x1 minus 5x2 factorial divided by product of 10 minus 3x1 minus 5x2 factorial and 1 factorial. Definitely, we will put summation sign before it, where lower limit of x1 and x2 is 0, and we will keep upper limit of x1 and x2 such that 10 minus 3x1 minus 5x2 is greater than or equal to 0. Putting all 7 ordered pair in summation, we get the same result. If you find content of this video useful, consider subscribing my channel. Thanks for watching.